Welcome back to Integrated Math 3 homework video. We're going to be over section 3C today, which is the multiplication of radicals. First thing I want to go over is the rules we learned last chapter with how to multiply algebraic expressions together will be used in this chapter as well. So the exact same rules, it doesn't change if you have radicals or not. For example, in this first rule that we have here, this is just the distributive property. So we're distributing the a to each term in the parentheses. In the second term, we're going to take the first terms multiplied together. Then we're going to take our outside terms, our inside terms, and the last terms. And the next two are just our perfect square expansion that we learned. And the very last rule is just remind you of our difference of squares. Let's try a few multiplication of radical examples. In this section, the directions are going to be expand and simplify. Problem number 1, I'm going to use the distributive property. So I'm going to take the square root of 3 and times it by the square root of 3 minus the square root of 3 times by the square root of 2. Square root of 3 times square root of 3 is just 3. And then I have minus the square root of 6. Okay, with example 2, let's try the distributive property again, this time with just 3 terms. So I have distribute the square root of 7 to the first term, then to the second term, finally to the third term. Then we're going to use our simplifying rules we learned in last section to get this as 2 times the square root of 7 plus 7 plus the square root of 14. One more example of the distributive property. This time we're distributing the negative 5 the square root of 2 to each term in the parentheses. We're going to multiply negative 5 the square root of 2 times 4 to get negative 20 the square root of 2. And then on this side I'm going to end up with positive 10. And then I have the square root of 2 times the square root of 2, which I can write as the square root of 2 times 2. We know that the square root of 2 times 2 is square root of 4, which is 2. So my final answer is going to be negative 20, the square root of 2 plus 20. Example 4, we're going to distribute that negative 2 the square root of 3 to each term. So timesing by 1, that gives me a negative 2 the square root of 3 times 1 minus the negative 2 square root of 3 times by a negative 2 the square root of 2. So anything times 1 is itself, so that's negative 2 the square root of 3, plus, we'll multiply the constants, the numbers outside, so 2 times 2 is 4, and then multiply the radicals, which will give us the square root of 6. Simplifying this down, we end up with a negative 2 the square root of 3 plus 4 the square root of 6. We cannot combine the 6 and the 3 since they are unlike terms. And this is all we can do for example 4. Now let's try multiplying two binomials together. So we're going to start with the square root of 7 times the square root of 7, which is 7. And then we're going to multiply the 3 times the square root of 7, and then the 2 times the square root of 7, and then the last terms together, which is going to give us a negative 6. Notice we have like terms in the middle, so let's combine those. But we're not done because 7 and negative 6 can also be combined to equal 1 minus the square root of 7. So this is our final answer. Okay, in example 6, we're going to multiply these two binomials together. So we're going to start by multiplying our first terms, which will give us 12. Our outer terms, which will be positive 6 the square root of 2. Our inner terms, which would be negative 4 the square root of 2. And our last terms, which will be negative 2. And then we have to multiply the square root of 2 times the square root of 2, which would be the square root of 4. And we know that the square root of 4 is equal to 2. And we also have like terms in the middle, so let's add those two together. And then finally, let's combine our 12 minus 4 to equal 8 plus 2, the square root of 2. Okay, in example 7, we're going to do a perfect square expansion because we got 4 minus the square root of 5 quantity squared. Now you can do these two ways. One method, you can do it just like we just did example 5 and 6. So I could rewrite this as 4 minus the square root of 5 times 4 minus the square root of 5. And then I could do my expansion. multiplying my first terms, my outer terms, my inner terms, and then my last terms together. Simplifying this down, combining the middle terms together, and then combining the two outside, the 16 plus the 5. Results in an answer of 21 minus 8, the square root of 5. The second way we could work this problem is using our perfect square expansion method. Okay, the perfect square expansion method says we take our first term of the binomial, which is 4, and we square it, plus 2 times our first term of the binomial times by the last term in the binomial, plus the last term in the binomial squared. Okay, let's work this. 4 squared is 16. That's going to be a minus 8 square root of 5 plus square root of 25, which is simply 5. Now adding the 16 and the 5 together, end up with the same answer we got the other method, which is 21 minus 8, the square root of 5. So these are the two ways that you can work the perfect square expansion problem. So here, we're going to try this again. I'm going to work it with the perfect square expansion method. So I'm going to take my first term and square it, plus 2 times first term in the binomial, times by the second term in the binomial, plus the last term in the binomial squared. That gives me 6 minus 2, the square root of 6 times 3, which is 18, plus 3. Okay, let's combine like terms. So 6 plus 3 is 9. But then I notice I have this square root of 18, which recall can be broken down to the square root of 9 times the square root of 2. And square root of 9 is perfect squared, so I can rewrite this as 9 minus 2 times 3, the square root of 2, which is 9 minus 6, the square root of 2. So you must simplify the radicals as we learned in our first section. The first thing I notice about example 9 is I have the same first term and the same last term, just my signs are different. So this is the difference of squares. So remember, the formula for the difference of squares is I take that first term and I square it, minus my second term in the binomial squared. So I got to distribute this square, so that's going to be 4 times this 5 minus 36. 4 times 5 is 20. We got 20 minus 36, which is negative 16. Example 10, we also have difference of squares here. So we're going to have the square root of 3 squared minus 4 squared. That gives us 3 minus 16, which is negative 13. Now I think you're ready to try some on your own.